Okay, limits. AP Calculus, Chapter 1, Limits. Example 1. Limit of x squared as x approaches 5. This is easy because we can directly substitute instead of x its value, which is the 5, so the answer is 25. Same here, it's 3 power 3, so it's 27. Now, here there is a fact, there is a rule that limit k of x as x tends to a equal k limit of x as x tends to a. Means k, for sure k is a constant number, so we can leave it alone and then we multiply it with the limit of x as x tends to a, and here we have an example. Its limit of 3 of x squared as x tends to 5, approaches 5. So we can rewrite it. We can leave it as it is and directly we substitute instead of x its value 5. We can rewrite the limit as 3 times limit of x squared as x approaches 5, and that will be as x approaches 5, and that will be 3 times 5 to the power 2, which is 3 times 25, and that is 75. If limit of f of x as x approaches a is L1, a certain number, and limit of g of x as x approaches a equal L2, then limit of f of x plus g of x as x approaches a is L1 plus L2. The answers of f of x and g of x. We can also substitute directly instead of 5 its value in x squared and x cubed in the example. We can rewrite it as limit of x squared as x approaches 5 plus limit of x cubed as x approaches 5 as in the above fact, and then we can substitute instead of x its value 5. The answer will be 25 plus 125, that is 150. Same in plus, same in times. If limit of f of x is L1 as x approaches a, and of g of x it's L2, then the limit of the product of f of x and g of x is L1 times L2, the product of their answers. So here we can rewrite it as limit of x squared plus 1 as x approaches 5 times limit of radical x minus 1 as x approaches 5. So it's equal to, we substitute it instead of 5, instead of x its value 5, it will be 5 squared plus 1 times radical 5 minus 1. So the answer will be 25 plus 1, 26 times radical 5 minus 1 is 4, radical 4 it's equal to 2. The answer is 52. For sure, also the same, we can directly substitute instead of x its value. Example 3. Okay, also we can substitute 0 plus 5 times 0, so the answer is 0. Now here is very important, limit of 1 over x squared as x approaches 0 equal, we can directly substitute instead of x its value 1 over 0. 1 over 0 is infinity, and we don't even care about if x is positive value or negative value, because what's the meaning of x approaches 0? Either it approaches 0 from the right hand or from the left hand, means either it's 0 plus or 0 minus. Since it's a squaring number in the denominator, so doesn't matter, it will give me a positive value, so 1 over 0 is infinity. While in example 5, limit as x tends to 0 of 1 over x, this will goes to two limits. It will goes to limit of 1 over x as x approaches 0 plus, and limit of 1 over x as x approaches 0 minus. As x approaches 0 plus, it's 1 over 0 plus positive 1 over positive 0, it's positive infinity. And 1 over 0 minus, positive over negative number, 0 minus is a negative number, so x approaches negative infinity. In this case, we can say that the limit of 1 over x as x approaches 0 does not exist. why it doesn't exist? Because the left hand limit does not equal to the right hand limit. 0 plus as x approaches 0 plus does not equal as x approaches 0 minus. So the limit does not exist. And here we go. Let's see this remark. If the left hand limit of a function is not equal to the right hand limit of the function, then the limit does not exist. A limit equal to infinity is not the same as a limit does not exist, but sometimes you will see the expression no limit, which serves both purposes. If limit of f of x as x tends to a equal infinity, the limit technically does not exist because it tends to infinity, right? So number 3, if k is a positive constant, then limit of k over x as x tends to 0 plus number, constant number, over 0 plus over positive number is 0, is infinity. And limit of k over x as x tends to 0 minus is minus infinity, and limit of k over x as x tends to 0 does not exist. While in the part 4, we can see as x tends to positive, k considered as positive value, and over x squared, so while x tends to 0 plus or 0 minus, both gives me the same infinity, which is positive infinity, and limit of k over x squared as x tends to 0 in general, in this manner, we can say it's infinity. Example 6. Limit of 1 over x as x tends to infinity. That is 1 over infinity, right? That is 1 over infinity. This means we are dividing the 1 over a very huge number. As the denominator increases its value, the answer tends to 0, right? So as if we are dividing 1 into a huge number of parts. So almost we got nothing, so it's 0. Limit of f of x of 1 over x as x tends to minus infinity, also at the same time equal to 0. Here 0 is an answer. We don't worry about whether it is 0 minus or 0 plus, because 0 plus 0 minus, both zeros. If k and n are constants, where x, absolute value of x, is greater than 1 and n is positive, then limit of k over x power n as x tends to infinity is 0, and limit k over x power n as x tends to minus infinity is 0. Let's find example 8. Limit of 3x plus 5 over 7x minus 2 as x tends to infinity. Okay, always as x tends to infinity, we can do that. As x tends to infinity, we can take only the highest, the coefficient of the highest power of x out of the coefficient of highest power of x in the denominator. So we can take 3x over 7x directly. The answer will be 3 over x. And why is that? We can factorize, take x common outside. It will be 3 plus 5 over x, right? Over also x into 7 minus 2 over x. When we simplify, x over x becomes 1. When we substitute infinity, the 5 over x, since it's 5 over x and x tends to infinity, 5 over infinity is 0, and minus 2 over infinity is also 0, and what left is 3 over 7. So directly we can, let's see example 9, we can take the limit as x tends to negative infinity, as if it's only, we don't have to do the same thing each time we do limits as x tends to infinity. We can directly, instead of factorizing, take 8x squared over 16 x squared, x squared cancel, so what left is 8 over 16 divided by 8, it will be 1 over 2. Example 10, we have time for example 10. Its limit as x tends to minus infinity of directly minus 3x power 10 over 33x power 10, x power 10 divided by x power